We're on lesson 8 of chapter 8, which we're going to factor polynomials completely. First we're going to factor by grouping, then we're going to factor completely, then we'll solve a real-world problem. First of all, whenever you have common binomials such as x plus 4 and another x plus 4, we can actually factor this out a little more completely than what this is listed here, kind of like simplifying. So for example, if I notice that the 2x is being multiplied times the x plus 4, then we have this minus 3 or negative 3 being multiplied times the x plus 4. I could take this 2x and this negative 3 or minus 3, put them together in a binomial, and multiply that binomial times the x plus 4. Because I still would multiply the negative 3 times the x plus 4, and I would still multiply the 2x times the x plus 4. So the answer would be exactly the same. Sometimes the binomials are not common, but they could be. So here I have y minus 2 and I have 2 minus y. So they're not the same, in fact they're opposites. Well, I know that 1 is the opposite of negative 1. So what I can do is I can multiply this whole section times negative 1, and then this would turn into y minus 2. Since I multiply this times negative 1, this becomes minus 5. So I'd be left with 3y squared minus 5 times y minus 2, which is now this 2. And this would give me the same answer as this. Let's try factoring by grouping now. So we have this polynomial with 4 terms. We have x to the third plus 3x squared plus 5x plus 15. By grouping terms together, then factoring out, we actually can get a complete factorization. So what do we mean by that? Well, I see that x to the third and x to the second are going to have a common factor, so I can group them together. I also see that positive 5x plus 15 also have a common factor, so let's group them together. So we have x to the third plus 3x squared. I could factor out x squared out of here, and that would leave me with x plus 3. I also have 5x plus 15. I can factor a 5 out of here, so this is a positive 5, and that would leave me with x plus 3. So if you'll notice, I've created the same binomial here. And just like we did in that last slide, I have x squared plus 5 both being multiplied by the same binomial. So I could have x squared plus 5 as its own binomial, multiplied times the x plus 3. And this is now completely factored. Now we have y squared plus yx plus x. Sometimes you have to do a little bit of guessing and checking when you do these factoring, but you kind of look for terms that would be alike. So here I notice an x, and the only other one that has an x would be this one. So I'm going to try to factor these two. Then we'll factor these front two. So I have y squared plus y. Then I have yx plus x. So of this one I can factor out a y, which would give me y squared divided by y, which is y. Y divided by y is 1, so y plus 1. This one I can factor out an x, and that would give me a y plus x divided by x is 1. And since this x I factored out was positive, it would be plus. So now I have y times y plus 1 plus x times y plus 1. They're both being multiplied times y plus 1, so our answer could be y plus x times y plus 1. Now I have x to the third minus 6 plus 2x minus 3x squared. So now you'll notice that maybe this might not be the best matchup for either one. Because I have x to the third here, and that doesn't really match up too well with this non-variable number. But I do have a 3x squared over here. So if I matched up the x to the third with the negative 3x squared, so x to the third minus 3x squared, then I matched up the negative 6 plus the 2x. If I'd write that in order, I'd just do 2x minus 6. Let's see if we can factor that out. In this one, I would factor out x squared. X to the third divided by x squared is just x minus, it would be 3 then. For this one, I would factor out 2. So it would be positive 2 I'm factoring out. And then it would be x minus 6 divided by 2 is 3. So you'll notice I can now perfectly factor this because they're both being multiplied times x minus 3. So my answer would be x squared plus 2 times x minus 3. So let's factor these polynomials completely. So just for your reference, there are many different ways to do this. First, you could find the common monomial factors if there are any. You could also turn trinomials into binomial factors like we were doing in previous lessons. Then you can also do some grouping like we were doing for those 4-term ones on the last slide. For this one, n squared plus 2n minus 1, if I look for this, I don't see any common monomial factors. So that means I can't do that. I have a trinomial here, so let's see if we could turn this into binomial factors. So I'm looking for two numbers that have a product of -1 but add up to +2. Well, I would need a positive and a -1 to give me -1, but that doesn't add up to 2, meaning that this can't happen either. And since it's not 4 terms, that means there's no factoring to do actually. So we would say cannot factor. How about this one? We have 4x to the third minus 44x squared plus 96. I notice that all these numbers are divisible by 4 and they all have at least one x. So I could factor out the 4x from this, and that would leave me with x squared minus 11x plus 24. And now you'll notice I have a trinomial that I can turn into binomial factors. I'm looking for two numbers that have a product of 24 and sum of -11. Well, 8 and 3 multiply to 24, and if they're both negative, that would add up to -11. Negative times a negative makes a positive product. So that would be my answer. I would have 4x times, and then I could do x minus 8, and then x minus 3. How about this one then? We have 50h to the fourth minus 2h squared. Well, I notice they're both factorable by 2, and they both have an h squared at least, so we could factor that out. 2h squared. So this would become 25 h to the second minus 2h squared divided by 2h squared is 1. So you'll notice here I have two perfect squares with no middle h term, without the h squared. And if you remember back to a previous lesson, that means it's the sum and difference pattern with the square roots. So the square root of 25h squared is 5h. Then it had to be 5h plus 1 and 5h minus 1 to give me a -1 product. So 5h plus 1, 5h minus 1, and then I have this 2h squared over here. For this final one, they gave me an equation, so I'd have to move this -24x over here. So I have 3x to the third plus 18x squared plus 24x equals 0. Well, I notice I can factor out an x out of all of these. I can also factor out a 3. So if we have 3x here, this would turn into x squared plus 6x plus 8, and that needs to equal 0. So now I can turn this trinomial into two binomial factors. I need two numbers with a product of 8 that have a sum of +6. 4 and 2 come to mind there. They would both be positive because they have a positive product and positive sum. So that leaves me with 3x. Then I have x plus 4, and then x plus 2, and that needs to equal 0. Remember, if either of these parentheses is 0, that's going to give me an answer of 0. So x then could be -4 to make this 0, or it could be -2 to make this 0. And these would be my two answers for this equation. Let's solve a real-world problem then. It says a terrarium in the shape of a rectangular prism has a volume of 4608, so 4,608 cubic inches. Its length is more than 10 inches. The dimensions of the terrarium are shown. Find the length, width, and height of the terrarium. Well, I know that the volume of the prism is 4608. And I notice that the length, width, and height of the terrarium all have W. To solve for volume, I have to multiply the length times the width times the height. So I could have 36 minus W times just W times W plus 4. If I multiply this first, that would give me W squared plus 4W. Then I have 36 minus W here. If I multiply using the FOIL method, I would have front 36 times w squared is 36w squared. I would do the outside, so 36 times 4w, which would be positive 144w. Next would be the inside, so negative w times w squared. That would be negative w to the third. Then finally we would have the outside, which is negative w times positive 4w, so that's negative 4w squared. That needs to equal 4608. So if I rewrite this in descending order and simplify, I would have negative w to the third. I have 36w squared minus 4w squared, so plus 32w squared. Make sure you know that's a plus sign. Plus 144w. Then I could subtract this from both sides of the equation, so minus 4608 equaling 0. If you notice, I have a polynomial with 4 different terms, and like we did earlier, we grouped them and then factored them out. I think we could do that again. I kind of like this grouping because we have w to the third and w to the second, so I have a feeling this grouping will work. If you look at these two, I notice they both have w squared. And I would like to get rid of this negative, so let's make that factored by negative w squared. So that's going to leave me with w over here, and then this is negative now, or minus, and then just 32. For these ones, I have a hunch that 144 is going to be a factor of 4608. So if I divide both of these by 144, that would leave 144 out here. It's plus 144 because it's positive. That would leave me with w minus 4608 divided by 144 is 32. That needs to equal 0. So now you'll notice these are common binomials, which means that I can refactor this. It would be a factor of negative w squared plus 144 times w minus 32. This one's not quite done yet because they're two squares as well. If you notice, we have a negative leading coefficient, which is never that good to have. So let's multiply this one times negative 1 to get that leading coefficient to be positive. So if we have negative 1 and then we have w squared, this will become minus 144. Then we still have our w minus 32, and that's going to equal 0. Squared variable, and we are missing the one variable, and we have the number. That's the sum and difference one. Since they're both squares, that's going to work. So we still have negative 1 here. We have w, and then 12 is the square root of 144, so w plus 12 times w minus 12. Then we have w minus 32 still, and that's going to equal 0. So any of these would have to be 0 to turn this answer into 0. So w could be negative 12. It could also be positive 12, or it could be positive 32. Well, I know it can't be negative, so we'll cross that off. Which one would be w? Could it be 32 or 12? Well, this hint will probably help me out here. Its length is more than 10 inches. I see the length here is 36 minus w. If I do 36 minus 32, that's going to only give me 4. So it would have to be 12. In that case, 36 minus w equals 24. So L for length equals 24 inches. W, which is the width, that's just going to equal 12 inches. And then the height is w plus 4, so 12 plus 4 is 16. So the height is 16 inches. Now that you've seen this once, I'd recommend watching this again, because you'll notice that we do this volume formula. We multiply to get our answer. We then factor out two different groups. Once we get our answer, we factor out the negative, and then have the perfect square with the one we had before, and that's how we got our answer.